Welcome to the CompTIA CySA Plus complete course designed to help you master the skills needed to pass the latest CompTIA CySA Plus certification exam and succeed as a cybersecurity analyst. This course is based on the newest CompTIA CySA Plus exam objective, including the latest updates introduced in June 2026. So whether you are preparing for the CySA Plus exam, advancing your cybersecurity career, or strengthening your SOC analyst skills, this course will provide practical knowledge, real-world examples, and exam-focused guidance every step of the way. So let's get started and take your cybersecurity skills to the next level. So hi everyone and welcome to the Cybersecurity Analyst CompTIA CySA Plus course. So this is another course in my CompTIA series. I have also already covered the CompTIA A Plus, Security Plus and Network Plus courses and they are available on my channel. So I have over 15 years of experience in cybersecurity and network security, and I have attained over 2 dozens of certifications in these specific domains, mainly the CISP, CCSP, CySA, JNCIP, SEC, etc. So if you have any query regarding any cybersecurity topic or the certifications, this certification or any other certification, you can email me or you can comment on the video and I will respond to your queries. So this certification course is designed as per the latest CompTIA exam version, that is CS0-004 V4, that is being launched at the end of the June 2026. So we have 4 domains and each domain carries a percentage of the overall exam weightage. So as we can see, the first domain, security operation, carries the largest 34% weightage. Second domain is vulnerability management, which is 26%, incident response and management carries 24%, and the last domain, that is reporting and communication, carries the smallest of all these domains, that is 16%. So there are a lot to cover and I will cover each and every topic that is available in the CompTIA exam objectives. So since I am covering each and every topic, so there are a lot of slides, particularly in this first domains. There are over, I think, about 170 slides. So I will try to make the things understandable as easy as possible, but I will also try to go through the slides in a fast manner so that we can cover all the topics in a short span of time and so that the video do not become too much lengthy. So without further ado, let's get started with the actual topic. And our first exam objective in domain 1 is explain concepts related to system and network architecture in security operations. And our very first topic is logging concepts. So what are logging? So logging is the process of recording events and activities occurring on systems, applications, network devices, security tools for monitoring, investigation, troubleshooting, and incident response. So you can relate this in your environment, in your IT environment, that each and every device, whether it is a network device, whether it is a server, or whether it is a mobile device, any activity or any action that is performed on them, they generate events and activity in the form of logs. And these logs are very important in IT and security operations. Why they matter? So these logging matters to detect security incidents. So from these logs, we can detect that something fishy or some security incident are happening. They support through investigation. When incident occurs, then we need to investigate these incidents. Sometimes there are criminal investigation, and for these investigation, the logs are very important. So there are some security compliance or regulatory compliance that require that these logs should be kept and stored for specific duration. So we also need these logs for these compliance requirements. So we also need these logs to monitor the health of all these devices, the network devices, servers, applications, etc. And again, in our criminal investigation, they also provide forensic evidence. So what is the log ingestion then? So log ingestion is the process of collecting and importing logs from the various sources into a centralized logging platform such as SIEM. So as we studied, all these devices, they generate logs. So instead of going through manually going manually into each device and going through these logs is humanly not possible. So what we do, we ingest these logs into a centralized platform commonly known as SIEM. So key components of this SIEM solution or this centralized solution include the log sources such as the firewall, endpoint, servers, cloud services, and applications. And these logs are ingested from these devices through protocols. These protocols include syslog, WinEvent, SNMP, NetFlow, and API-based collection. So these are the different protocols that are used by different devices. So for example, a network device may use the NetFlow protocol for with its communication with SIEM solution to send its logs. The Windows Server, Microsoft Windows Server may use the WinEvent. So each device and application use a specific type of protocol. So we have some popular SIEM solution or platforms such as Splunk, very popular, QRadar from IBM, very popular, and the Microsoft Sentinel. These are primary ingestion points, or you can also say these are primary SIEM platforms. So in order for the logs to be ingested by the SIEM solution, we need to configure logs on these devices as well as the SIEM platform. So log configuration determines what events are recorded, how much detail is captured, and where the logs are sent. So these all details needs to be configured. So the key components during log configuration include the log level. So we have different level of logs such as debug, info, warning, error, and criticality. Critical, as you can see that the severity of these log increases from debug to fatal. So we won't want to miss any fatal or error related logs. We may want to miss or even not configure the info logs. So because misconfiguration may lead to either log gaps, so it will be very critical if we miss these logs because these are very important for our system and security operations. But if we configure all type of info logs, then we may generate very excessive noise. That means that we have a lot of logs that are of no use or of very little information to us. So the best practice is to log the minimum necessary information so that we can detect threat, and we also do not overwhelm our storage requirements. So remember that all these logs are stored somewhere. So if we log each and everything, our storage requirement or our storage will be overwhelmed, and then it will be cost prohibitive. So we need to detect all the critical logs that are necessary for our security operation, and we fine tune our logs such that the unnecessary logs or the logs that are of very little information, we can let them go. So exam tip is that too little logging reducing visibility. For example, if we configure only, let's suppose, some fatal logs and we leave out the error or warning logs, we may have the reduced visibility. On the other side, if we log all the levels of logs, we may have very much noise, that is very a lot of information which will be of very little use, and our storage needs will also be very large, and our storage solution will be overwhelmed. So as we study that the logs are basically very important information. These are the critical data from all the systems. Sometimes they are used for forensic investigation, for incident investigation. So the integrity and security of logs is very important. For example, if there is some hacker that intruded inside our systems, stole some data, and if that hacker is able to delete the log or change the log, then we are in a trouble. So the security and integrity of logs is very important. So ensuring that logs remain accurate, complete, and protected from unauthorized modification is very important. So why it is important? Because attackers often attempt to delete, modify, or disable logging to cover their tracks. And protection methods for logs include to encrypt the logs on storage, to use digital signatures so that we can determine that logs are from the original source. Hashing is used for integrity, which ensures that the logs are not tampered with or they are not changed. Write once storage and centralized logging. Write once storage means that once we write the logs to that storage, they cannot be changed. And again, centralized logging is also important. For example, if your server is compromised and the logs is also stored on that server, the hacker can easily delete or change that log. But if the server is configured to send the logs to SIEM solution, then this is centralized logging, and if your SIEM solution is secured enough, your logs from that compromised servers are safe, and you can use them to track that hacker and for other investigations. So time synchronization is one of the very important aspects in logging, and we can see why. So we need to ensure that all the devices use the same accurate time source when generating logs, so that we can correlate these logs with each other. So if we have different time at different system, it will be very difficult to know the exact nature of events that occurred during an incident. So why it is important? So without synchronized time, event correlation becomes difficult, attack timelines become inaccurate, and incident investigations become delayed. So the common technology or the common protocol that we use for time syncing among devices is the NTP, that is Network Time Protocol. Another important aspect is log retention. So log retention is the process of storing logs for a specific or specified period according to business requirements, operational requirements, or legal and regulatory requirements. So why the log retention is important? Because it supports an investigation. Let's suppose if there is something happens and in the future the company decides an investigation, or some agency or government institution decides investigation. So it is very important that you have stored those logs that they can support the investigation. So the government or the regulatory agencies may also require some compliance that you need to adhere to, and these may be to store these logs for specific period, enable historic analysis, and provide evidence for audit. So during audits, the auditor may require the logs to certify certain criteria or to look for certain events and other requirements. So consideration during log retention should be storage capacity. So again, as we studied, those logs that are required for compliance requirements that are critical, they should be stored, and other logs that are of little or no use to for the compliance requirement, they are of no use for the audit purposes and other needs, the business needs. So keeping in view the storage capacity, we may want that these logs that are of no use and no importance are not stored. Regulatory compliance is very important. That should be keep in mind when talking about the log retention. Again, your own business policies and investigation needs. So our next topic is operating system concept. So you all know the operating system by itself. our popular operating system, the Microsoft, that is Windows, Microsoft Windows that I'm using right now, Apple macOS or iOS on mobile devices, Android, and of course the Linux. So why the concept of operating system is important for cybersecurity analysts? So analysts must understand operating system internal to detect anomalies, investigate incidents, and analyze logs and recommend hardening. So key OS operating system platforms include Windows, which is most common in enterprises, and it main focus for the analyst is on registry, event logs, and processes. Linux is most common in server and cloud platform, and focus in Linux is on configuration files, permissions, and daemons. And macOS is less common in enterprises, but it is relevant in mixed environment. It is mostly used in user end devices such as laptops. So what is system hardening? So it is the process of reducing the attack surface of an operating system by applying security best practices, patches, and configuration. So what are the goals of system hardening? So the main goal is to improve security, reduce the attack vectors, limit the unauthorized access, and minimize the exploitation opportunities. So what are some common techniques of system hardening? So some common techniques include, the most important and the foremost is to disable unnecessary services or ports. So unnecessary means that they are not used for any business purposes, they are not used in your operations. They need to be disabled, so that when we say to reduce the attack surface, so this is the reducing the attack surface. If a service or a port is not available, is disabled, the attack surface is automatically reduced and it can no longer be exploited. Again, to remove the unused software and unused accounts. So for example, if there are some guest accounts, if there are some user accounts that are no longer used, they should be immediately disabled and removed. Apply security patches and updates regularly from the vendor. For example, if you are using Windows, you need to apply Microsoft released patches and updates as soon as they are released. And enforce least privilege on all accounts. Least privilege means that all the accounts should only have the permissions that they need to do their job and day-to-day tasks. And to enable host-based firewall, so each operating system has its inherent firewall, so that need to be enabled. For example, Windows, Linux has IP tables firewall, Windows has built-in Windows firewall, so you need to turn them on. So now coming over to file structures of these operating systems. So a file structure refers to the organization and storage of files and directories within an operating system. So for example, Windows file structure is, you can see that the core system files are stored in this directory, C, Windows, and System32. Then we see Windows, System32, and config have the registry hive. Registry files are stored over here. And C program files has the installed application, while the C users and then the username, it is where the user account data is stored. Coming over to Linux file structure, so we have the etc, most important directory where the configuration files are stored, /var/log. So we are talking about logs in a moment before. So this is where these logs are stored on the individual systems. For example, the syslog, path.log. Then we have the /bin and /usr/bin. So these are the directory where we have the executables, and then we have the /home where the user directories are available. So what are some critical files in these operating systems? So these are the files that contain sensitive configuration, logs, or system data, and these are the high value targets for the attackers because again they are critical and they have the sensitive configuration and information. So some critical Windows file structure includes SAM that stores local user password hashes and which is a lucrative target for credential dumping, ntds.dit which is Active Directory database and again it is a high value target for attackers. Host file, it is the file that stores the DNS records and it can be modified by the attacker to redirect the DNS queries, and then registry hiles, it contains configuration, auto-run entries and persistent mechanism. Some Linux file structures, so we have the critical files such as etc password and etc shadow. So these two directories stores the user accounts and the password hashes. /etc/cron tab are where the scheduled tasks and are stored, and it may be abused for persistence by the attacker. .bash rc and /bash_profile, it is where the startup scripts are stored, and again it can be used for persistence. It is being in fact used for persistence. And then we have the /etc/sudoers. So these can be targeted by the attacker for privileged escalation. Now coming over to some system processes. So running the program and services, these are the system processes are running program and services managed by the operating system, and analysts may look for, should look for normal versus anomalous processes. So if you know what are the normal program and services that are run by a different operating system, you can also then detect anomalous processes that are not available in a normal operating system. So key characteristics are that legitimate processes usually have non-parent processes. For example, the service host.exe has the services.exe parent, or you can say that this process basically inherits comes from this one. And if there is high or CPU or memory usage or unusual high network activity or unusual network connection, it means something fishy is going on and this is a red flag. So some Windows common processes include ISS.exe, which is used for credential handling and often targeted by attackers, SMSS.exe and CSR/SS.exe, including WinInit.exe. These are core system processes, and of course Explorer.exe, which is a user shell in Windows. Then we have some common Linux processes are also known as daemons in Linux. So these are ps-top and htop, and these commands are these processes basically list all the running processes in the operating system. /proc file system is the shows us the live process information. So unexpected root-owned processes deserve immediate investigation of the analyst. So our next topic is infrastructure/system architecture concepts. So why this topic is important for the CySA analyst? So understanding modern infrastructure helps identify misconfigurations, attack surfaces, and anomalies in hybrid and cloud environments. So key modern architectures include cloud native, virtualization, containerization, and APIs, and we will go through each of these one by one. So first one is cloud native. So what is cloud native? Cloud natives means that the applications that are built and deployed entirely within cloud platforms such as AWS, Azure, or Google Cloud Platform key characteristics of the cloud native applications are that they are based on microservices based architecture. They have the auto scaling and elastic resources capability, and these managed services basically replace the traditional on-prem infrastructure. So security challenges of these cloud native infrastructure is that we have now a shared responsibility model. So we have the cloud provider that secures the physical infrastructure, the server, the network devices, the physical security of the data center, while the customer mainly secures the data and access control. So another challenge is that misconfigured storage bucket and identity and access management policies are top cloud attack vectors. So now since we are inside cloud is accessible from anywhere through internet. So if you have a misconfigured storage bucket, storage address, so that is a very top cloud attack vectors because now this is accessible from anywhere, and if it is misconfigured and the data is also accessible, then we are in trouble. So again, we have limited visibility compared to on-premises environment. So in cloud, we don't have the hypervisor level or the hardware level visibility that we have in on-prem. So again, we have limited visibility inside the cloud as we have in our on-prem environment. So our next topic is virtualization. So virtualization is running multiple virtual machines on a single physical host using hypervisor. So we said multiple things. VMs are virtual machines as compared to physical machine, and these are produced or orchestrated through a hypervisor. So what is a hypervisor? So we will study these now. So these are the types of hypervisor. So hypervisor is basically, you can say that this is your physical host. On top of that host, you deploy hypervisor. So traditionally, we used to deploy operating system directly on that host. Now you deploy the hypervisor, and as we can see over here, we are already have this in diagram. This is your physical host. You have the hypervisor on that host. So this is, you can say, the virtualization OS, you can name it. And on that hypervisor, you can then have multiple VMs. So each VM has its own operating system. It may be Windows, it may be Linux, and you can have tens and hundreds of these VM on a single host. So we have two types of hypervisor. Number one, that is typically used in data center and enterprise environment is type 1, that is bare metal. So in this case, hypervisor run directly on hardware, such as in this case. An example of type 1 hypervisor are VMware ESXi, Microsoft Hyper-V, and Xen. So this is the type 1. As we can see, we have the physical host, and on this host we have directly installed the hypervisor, and then on using the hypervisor we orchestrate multiple VMs. Number 2 is type 2 hosted, also known as hosted hypervisor. So this type of hypervisor run on top of host OS, for example VirtualBox and VMware Workstation. For example, if you install Windows operating system over here, and then on this Windows OS you install hypervisor over here. So this is type 2, and inside this hypervisor then you create VM. This is the type of hypervisor that we usually use on our laptops, such as the VirtualBox or VMware Workstation. So some security challenges in virtualizations include VM escape. So it is a phenomena where attacker breaks out of VM to access hypervisor or other VMs. VM sprawl is where we have unmanaged VMs that increase the attack surface. Snapshots that we create using virtualization may contain sensitive data if not properly secured. So if you create a snapshot of VM, they should be properly secured, because if they contain sensitive data and they are compromised by the attackers, it means we may lose that sensitive data. So hypervisor compromise affects all hosted VMs. So since hypervisor is the platform that manages all those VMs, so if this hypervisor is compromised, it means all your related or hosted VMs are, you can say, compromised as well. Our next topic is containerization. So containerization is a lightweight virtualization method that packages application with their dependencies into container. It runs on shared OS kernel. So if we see here, we have again a physical host, a server. So as against the virtualization, instead of hypervisor, we have the host operating system. This may be Linux, this may be Windows. On top of that, we have the, you can say, containerization engine or Docker engine, and on top of that, we have the containers, and inside each container, we have the application. So each container has all the libraries, the dependencies that are required for these applications. So this gives us very, you can say, lightweight, if you say these VMs. So in the case of VMs, each VM has its own operating system. Here, the container do not have its own operating system. It uses the operating system kernels, shares it. It is shared among all the containers. So that's why it is very lightweight. It only has the required libraries that are used by the application. So characteristics, again, it is very lightweight as compared to VM. It has fast deployment, so you can you can take this container and you can fastly deploy it anywhere else that has the same Docker engine and same operating system. Very portable. As I said, it is portable and it is consistent across environment, because it carries along the same libraries and dependencies to each environment. So some you can say the comparison between the VMs and containerization. So size is that the virtualization VM is large because it has full OS, and the containers are small because we have the application only and its dependencies. Startup time of VMs are slow because it needs to start the complete operating system. The startup time of container is very fast because it does not need to start all the full operating system. It needs to run only the required libraries and dependencies. Isolation inside the virtualization between VMs is strong, which is controlled by the hypervisor. In containers, it is weak because the containers share the same operating system kernel, and density of the VMs is lower, while in case of containers it is higher. Density means that you can, let's suppose if you can deploy 100 VMs on this specific server, you may deploy 200 containers on the same server because the containers require less resources, so their density is high. So security concerns are again container escape. These are for container. Same like the VMs, we may have the container escape from this environment and privilege escalation. Insecure images of container, exposed faults and weak secrets management, and supply chain attacks. That is, if the container base image is compromised, all the resultant containers will also be compromised. Our next topic is API, that is application programming interfaces. So an API is a set of rules and mechanisms that allow applications and systems to communicate and exchange data. So common API types include REST API, which is most common and uses HTTP methods, that is GET, POST, PUT, DELETE. Then we have the SOAP API, which is XML based and is used in legacy enterprise environment. And lastly, we have the GraphQL, which is a flexible query based API. So what are some security concerns with the APIs? So the broken object level authorization, that is BOLA, is accessing other user data. So this is one security concern. Next is API key exposure. So hard-coded keys in source code or public repository may be exposed. Excessive data exposure. So APIs returning more data than needed may expose data. Rate limiting bypass, so enabling brute force or enumeration attacks through APIs. So what are some controls? So some API security controls are authentication of the APIs, authorization, their rate limiting, encryption, and input validation. So now coming over to our next topic, which is device management concepts. So the processes, technologies that are used to securely manage, monitor, and control various devices in an organization's environment. So main categories of device management include MDM, that is mobile device management, and endpoint device management. So why device management is important for CySA plus analyst? So it is because devices are common entry point for attacks, whether they are mobile devices or whether they are endpoint devices like servers. So we need to protect, we need to detect anomalous behavior inside devices, enforce security policies, and respond to the incident in these devices. Mobile device management, that is MDM. So it is the centralized management of mobile devices such as smartphone and tablet to enforce security policies and ensure compliance. So the key capabilities that MDM provides include the remote wipe that can be used to erase device data if it is lost or stolen. Policy enforcement includes enforcing the PIN on the device, encrypting the data on the device, and application restriction. App management gives you control on the device such that which applications can be installed and which application cannot be used or installed on the device. And geolocation tracking, so you can locate the device when it is lost or stolen. So common MDM platforms include the Microsoft Intune, VMware Workspace ONE, JAMF from Apple, and Google Workspace. So some security risks with the mobile devices include that they may be jailbroken or rooted, and such devices can bypass the security controls, including that of the MDM. So unmanaged personal applications can leak the corporate data. So lost devices that do not have the remote wipe capability have the risk of data breach, and public Wi-Fi usage on these devices exposes the data on these devices as well as the traffic interception that goes through these devices using the public Wi-Fi. Next is the endpoint management. So endpoint is managing and securing the endpoints that include the laptop, desktop, servers, and workstation throughout their life cycles. So key components of endpoint management include endpoint protection platform, that is EPP, and these include the antivirus, firewall, and disk encryption. Endpoint detection and response, EDR, which is the continuous monitoring, behavioral analysis, and threat hunting. And unified endpoint management, UEM, which combines the MDM and traditional endpoint management. Some security concerns with the endpoints include that the unmanaged or rogue endpoints can introduce blind spots, Outdated software and missing patches are the primary exploit targets for the attackers. So lateral movement through endpoint often occurs after the compromise of one or more endpoints. Lateral movement means that going from one device to next and next within the organization after one device is compromised. USB and removable media can bypass perimeter controls. So since these have no network connectivity, the perimeter security such as firewall can be bypassed through these portable and removable media. So what is the difference between endpoint management and mobile device management? So mobile device is basically include the smartphones and tablet which are mobile, and endpoints are laptop, desktop and server. Mobile devices are managed through MDM, mobile device management, while the endpoints are managed through EDR and EPP. So the mobile device has the flexibility and focus on mobility, while the endpoints are basically used inside the enterprise systems. Mobile devices has the risk of loss and theft, while the endpoint has the risk of malware and hacking or other compromises. So next topic is network architecture concepts. Network architecture refers to the design and structure of network components, connections, security controls, and access methods within an organization. So why does the network architecture concepts matter? It is because modern networks are complex and distributed. Analysts must understand these architectures to detect misconfiguration, monitor threats, and recommend secure design. So as long as you don't understand how the packet goes from one device to another, how the data flows inside the network, what is the network components that come together, what is the TCP/IP, all these concepts are very important. So as long as you don't understand them, you cannot secure them. So for security, first you need to understand the basic of networking, the basics of operating systems such as Linux, and then you can secure them. So some modern network architectures include the Zero Trust Network Architecture ZTNA, Secure Access Service Edge, SAS, also called as SASE, and the Hybrid Cloud. So the first one is Zero Trust Network Architecture, or ZTNA. So it is security model that assumes no implicit trust. This means that every user, every device and application must be continuously verified before granting access. Never trust, always verify. So traditionally the slogan was trust but verify. Zero trust architecture slogan is that you should never trust and always verify, even if the device or the application is inside your perimeter or inside your organization. So no user, device or application is trusted automatically, even if it is located inside the corporate network. Every access request must be authenticated, authorized and continuously validated. So what are the core principles of the Zero Trust Network Architecture? So these include, as we said, verify explicitly. It means that every access request must be authenticated and authorized regardless of the location of the device. Least privilege access means that user receive only the permissions required to perform their job, no less, no more. And assume breach, which means that the organization operate under the assumption that attackers may already be present inside their network. Next is the Secure Access Service Edge, or SASE. This is the cloud native framework that converges the network security and wide area networking WAN into a single service delivered from the cloud. So some SASE components include the SD-WAN, that is software defined wide area network. So it is the software defined wide area network for optimized connectivity of WAN. CASB, which is Cloud Access Security Broker, that gives visibility and control over cloud application usage. SWG, that is Secure Web Gateway, that gives us the filtering capability of malicious web traffic. And as we said, ZTNA, which replaces the traditional VPN based security with identity based access. And FWAS, or Firewall as a Service, which is cloud delivered next generation firewall. So key benefits of SASE include that security and networking are delivered from the cloud, no on-premises appliances are required or included in this architecture, consistent policy enforcement regardless of the user location. It is ideal for remote workforce and branch office environment, and it reduces complexity of managing multiple point security products. So why this architecture is relevant for security analysts? So all traffic flows through SASE platform, which gives us a centralized visibility. So logs from SASE feeds are directly fed into SIEM solution for correlation. Some vendors of this platform include Palo Alto Prisma Access, Cisco Umbrella, Zscaler, and Netscope. Our next topic is hybrid cloud. So what is hybrid cloud? So IT environment that combines private cloud or on-prem or dedicated. So the private cloud may be on-prem or dedicated, and when we combine it with the public cloud, which may be from Amazon, AWS, Microsoft Azure, or Google Cloud Platform services connected for data application sharing. So in a nutshell, the hybrid cloud is basically the combination of the public cloud, private cloud, and traditional on-prem infrastructure. When you mix these things, for example, when an organization has the on-prem infrastructure as well as a public cloud, they have the hybrid cloud environment, or you can say they have the hybrid environment. So some architecture components of the hybrid cloud include the on-premises system, which are legacy systems that may include sensitive data, and some application that may require low latency, that why they may be kept on-prem. Private cloud is dedicated cloud environment for a single organization, such as some government agencies or for some government department. Public cloud is shared infrastructure that is shared among multiple customers, such as AWS, Azure, and GCP. And the orchestration layer basically manages the workloads across all the environments, such as the on-prem and the cloud, the public cloud environment. So some security challenges of the hybrid cloud, and the first one is inconsistent invisibility. So different logging and monitoring tools across environments. So in hybrid environment, you have the traditional on-prem infrastructure, you may have the public cloud. So for both of these environments, you may use different tools, and so you may have inconsistent visibility of your overall environment. Next is identity sprawl, again managing users and permission across different environments. So you may have identity sprawl. Data sovereignty, that is ensuring data stays within the required geographic boundaries. So in traditional on-prem infrastructure, we don't have the data sovereignty issue, but in public cloud, this issue is particularly of importance in public cloud, because your data may reside somewhere else in some other country, while there may be regulation that required, such as GDPR, which is a EU law that requires that EU citizens' data should reside inside the EU boundaries. So, it is data sovereignty also may be issue when you are using hybrid cloud environment and some of your data is inside public cloud. So, for such cases, the sensitive data organization do such that the sensitive data is stored on-prem while other non-sensitive data and for non-sensitive tasks they use the public cloud. Misconfiguration risk, so hybrid cloud increases the complexity and there may be chances of misconfiguration and security gaps. Shadow IT is unmanaged cloud usage outside IT visibility. Our next topic is identity and access management, that is IAM concepts. So, identity and access management is the framework of policies, processes and technologies that manages digital identities and control access to resources. So, what are the digital identities? One example is username and password, digital certificates. These all are digital identities. And what are the parameters or what are the components of IAM? These include authentication, authorization, then user management and central repository for all the digital identities and users. So, key features of the identity and access management include that it may provide us with the single sign-on solution, role-based access control, attribute-based access control, just-in-time access identity for privileged users and federation, for example, through SAML and OAuth. So, common platform for digital for identity and access management, important ones are Microsoft Entra ID, that is Azure AD. Previously, it was known as Azure AD, Okta, and Ping Identity. Inside identity and access management, we have the privileged access management or PAM. So, it is the subset of identity and access management and is focused on securing, monitoring and controlling privileged accounts. So, privileged accounts are those that have the more access, or you can say the most access inside the environment. These accounts can do nearly all the tasks that other accounts can't. For example, the admin account in some system, they are user account, similarly service accounts. So, these accounts have elevated privileges. So, what are the core privilege access management system capabilities? So, they may give us the privileged account discovery. So, for example, we have this new system, we introduce it inside our organization, our environment. It may help us identify our privileged accounts across the environment. Just-in-time access is granting elevated privileges only when needed and auto-revoke after use. So, since the privileged accounts have the escalated privileges, it is very risky to use them all the time for all the tasks. So, they are only used when they are required and then automatically revoked. Session recording, so record and audit all privileged sessions. So, whenever the privileged accounts are used, their tasks, their actions are recorded for audit purposes. Password vaulting is to store and rotate the privileged account credentials automatically. Next is the authentication and authorization methods inside identity and access management. So, authentication is verifying who you are or who are you, usually through a username and password. Authorization is what you are allowed to do after authentication. So, after authentication, we have the authorization, and inside authorization, the user is allowed to do certain tasks. So, both of these must work together. Authentication without proper authorization still leads to breaches. So, if you authenticate a user but you give this user unnecessary privileges and access to unneeded application, this may also lead to breaches. So authentication methods, authentication is verifying the user identity. There are multiple authentication methods such as something you know. These include the password and PIN, something you have, such as token, smart card, and authenticator app usually on your smartphone, something you are, such as your biometric, your fingerprint, your facial recognition, and somewhere you are, which is location based. And so if you combine multiple of these, for example, something you know and something you have, then this type of authentication method is known as multi-factor authentication, and there are also passwordless authentication. For example, if you combine the biometric and the authenticator app, you have a passwordless authentication method. What are some authorization methods? So these include RBAC, that is role-based access control, where access is based on the job role. For example, finance user may have a separate role, HR have a different role, IT department have different roles. So based on these requirements, we may have different role, and user in these departments may be given users according to these roles. ABAC is attributes-based access control, where access is based on user attributes and context. MAC is mandatory access control, where access is based on security labels and clearance level. So these are system enforced access, and these are used in very high security environment, such as in military and other intelligence agencies. DAC is discretionary access control, where resource owner control access permissions. So some key protocols in authorization and authentication, these include SAML, which is XML based single sign-on for web application. So for SSO in web application, we use SAML. OAuth 2.0 is authorization framework for API access delegation. OpenID Connect or OIDC is identity layer on top of OAuth 2.0. Kerberos is ticket-based authentication used in Active Directory environments, and LDAP is Directory Service Protocol for user authentication and lookup. So our next topic is secret management. So what is secret management? It is the secure storage, rotation, and access control for sensitive credentials, API keys, certificates, and encryption keys. So key practices for secret management include a centralized secret vault, automatic rotation, least privilege access to secrets, auditing and monitoring of secret usage, and to avoid hard coding secrets in code or configuration files. Some common tools for secret management include HashiCorp Vault, AWS Secret Manager, Azure Key Vault, and Google Secret Manager. So now coming over to encryption techniques. So encryption converts readable data, that is plain text. So what we are seeing here is plain text into unreadable format, that is ciphertext, using algorithms and keys. So data protection encompasses broader strategies to safeguard information. So these are some types of encryption. You must know and differentiate between them. So symmetric key is the type of encryption that uses same key for encryption and decryption. And some popular example of symmetric keys are AES, that is Advanced Encryption Standard, AES 256192. So this is the 256 is the length of the key, and triple dash. Then we have so for data encryption in VPN, for data encryption on storage, we usually use the symmetric because it is efficient and it is fast for bulk data encryption. You should remember this point. Asymmetric is also known as public key encryption. So in this case, we have two different keys, one public key and one private key. So if you encrypt with one key, you can decrypt with other. For example, if public key encrypts, the private key decrypts, and vice versa. If private key encrypts, the public key decrypts. And the example of asymmetric encryption include RSA and ECC. Then we have the hashing. So hashing is not actually, you can say, an encryption. It is a one-way transformation and it is not reversible. What does this mean? This means that if you pass this text through hashing algorithms and you have some type of hash, you cannot convert this hash back to this plain text. So why then hash used? So hash are used for integrity. You convert text to hash, you send it to the user. The user over there then convert the text again to the hash. The user then receiver compares the two hashes, one that is converted by the user himself or herself and the other that was received with the text. So if both of these hashes are same, it means the data was not tampered or corrupted during transmission and data integrity is intact. So hashing is used for data integrity. Some common example of hashing algorithms are SHA-256 and MD5. Hybrid encryption, where we combine both the symmetric and asymmetric, such as inside TLS and SSL. So why we use hybrid? So as I said, we use symmetric encryption for data encryption, while asymmetric is used for the transportation or for exchange of symmetric keys. So if we have this party A and party B, if they want to encrypt data using the symmetric key, so how as we said, in symmetric they must have the same key. So how this key is exchanged? If A is in, let's suppose they are geographically distant in some different countries, so for this key exchange, for secure key exchange, we use the asymmetric encryption, and for data encryption we use the symmetric encryption. So that's the use cases of symmetric and asymmetric. So in use cases, encryption may be used for data that is stored in storage, for data at rest. So it is used for encrypting data stored on disk and databases. For example, we have the BitLocker inside Windows. We can use it to encrypt data inside our hard drive. Similarly, AES, as we studied, is the symmetric encryption algorithm. It can be used for data encryption at rest. So AES or symmetric encryption is very, very fast and efficient. So for bulk data encryption, we use AES. Data in transit is protecting data moving across networks, and for data in transit, we usually use VPN such as IPsec, HTTPS, and TLS 1.3. And data in use that is actually used by the user, or the data that is actually inside the processing or memory. So protecting data while being processed, and for this we have emerging techniques such as confidential computing. So key management concepts include, or we can say the best practices of key management include: key management is the most common encryption failure. So if your key management is poor, if your keys are, let's suppose, compromised, your encryption will also fail. Key must be rotated regularly and stored securely. Rotation means that the keys must be changed regularly and they must be securely stored. So compromised keys render encryption useless regardless of the algorithm. So even if you have very strong algorithm and very long and strengthy key, but if the key is compromised, everything else is useless. So now coming over to data protection concepts. So the core principles of data protections are confidentiality. So confidentiality is mainly ensured through encryption and access control. Confidentiality is the basic principle, which means that data should only be accessible and visible to authorized users. Then we have the data integrity. As we said in the previous slide, for integrity we use hashing, and integrity means that data must be intact and complete, and it must not be changed or tampered. So we use hashing, digital signatures, and checksum for data integrity. For data availability, we have backups, redundancy, and RAID. RAID is redundant array of independent disks. So it is combining multiple hard drives for redundancy, so that let's suppose if one drive fails, we can still recover the data from the redundant drive. So what are some key data protection methods? So as we studied data at rest, for data at rest we use disk encryption or database encryption. For data in transit we use TLS, IPsec, and VPN. For data in use we use memory encryption and secure enclaves such as TPM. We also use practices such as data masking, tokenization, and anonymization, and we use tools such as data loss prevention to prevent data exfiltration outside the organization. So some best practices for data protection are to do the classification of data. So data should be classified such as public, private, and confidential, so that the controls are applied accordingly. So for the public data we may not use any control, but for confidential we may use control or a set of multiple controls. Then we use the key management and rotation as we studied in the previous slides, and regular backup of data with immutable storage. Immutable storage means that the storage data on the storage should not be changed. It should be write once storage. So key data protection frameworks include GDPR, which is a European data privacy regulation, very important. HIPAA is a US healthcare data protection that is used for protection of patients' data in healthcare system. PCI DSS is payment card industry data security standard that is used for protection of payment card data. And NIST SP 800-53 is a comprehensive security and privacy control framework. Now coming over to critical infrastructure concepts. From critical we mean the power grids, the nuclear energy, and other industrial setups. So systems and assets that are essential for society's functioning such as energy, water, transportation, healthcare, etc. So why these are important? So these environments are of high value targets for nation state actors and ransomware. So CySA analysts may deal with OT and ICS security incidents. So inside ICS we have the operational technology or OT. So OT refers to hardware and software that monitors and controls physical devices and processes. Unlike IT systems that processes data, OT systems control physical world operations. So they are found in power plants, manufacturing facilities, oil and gas pipelines, and water treatment plants. So what are some OT security challenges? So these include the legacy systems are not designed with security in mind. So these systems are generally air-gapped network, and air-gapped network increasingly connecting. So traditionally these systems were air-gapped, but now they are increasingly being connected with the IT, and IT, as we know, have the inherent security risk. So vendors often require direct remote access to these systems for maintenance. Patching of this system is increasingly and extremely difficult because we cannot take these systems offline for patching or for testing the patches on this system. And traditional IT security tools can crash or disrupt OT equipment. So industrial control systems. So ICS is the broad category of systems used to monitor and control industrial processes. So it encompasses OT environments across all critical infrastructure sectors. So industrial control system components include PLC, that is programmable logical controller, which executes control logic for physical processes, for example open valve, start motor. RTU is the remote terminal unit that collects data from field devices and sends it to control center. HMI is human machine interface, that operate interface for monitoring and controlling processes. And historian is the database that records process data over time for analysis. So I see some industrial control system attack example. So Stuxnet, a very popular malware that was designed for the Iranian nuclear facility and centrifuge. So this malware destroyed Iranian, or you may say damaged Iranian nuclear centrifuge by targeting the PLC, programmable logical controller. Then we have the Ukraine power grid attack in 2015 and 16, and similar attacks also happened after the Ukraine-Russian war. So ICS attack caused widespread power outages. Then we have the Old Smar water treatment in 2021, where the attacker attempted to poison the water supply via the ICS access. So as we can see from these attacks, the security of ICS is very critical. So what are some best ICS security practices? So network segmentation between IT and OT ICS network. Because the IT network is accessible if it is not air-gapped from anywhere through internet. So it is very important that these two networks are air-gapped and segmented. So application whitelisting on ICS workstation. So the workstation that are connected to ICS, they must have application whitelisting. Whitelisting means that you allow only the required application that are required to run these control systems, and no other application should be allowed to work or install on these systems. Strict remote access control with multi-factor authentication and regular backup of PLC configuration and logic. Then we have the supervisory control and data acquisition, that is SCADA. So SCADA is a type of industrial control system that is used to monitor and control geographically dispersed infrastructure. It collects real-time data from remote field services and provides centralized visibility. It is common in utilities such as electricity, water, gas, oil pipelines, and transportation systems. So SCADA architecture include field devices, which are sensors and actuators at remote sites, RTUs and PLC that collect field data and execute commands, communication network that link field sites to control center through radio, cellular or fiber communication. Master station or MTU is the central control and monitoring point, and HMI SCADA software where we have the operator interface for visualization and control. So some SCADA security concerns include, so SCADA was originally designed for reliability, not security, and there are no built-in authentication in many protocols. So increasing internet connectivity exposes the previously isolated system to various risks. So the SCADA use proprietary protocols such as Modbus, DNP3 and IEC 61850 that lack encryption by default, and they have single point of failure, so compromise of master station affects the entire infrastructure. So our exam objective 1.2, given a scenario, analyze indicators of potential malicious activity. So let's get started. And the first topic is network indicators. So what are some indicators over the network of a malicious activity? So network related indicators are unusual or suspicious network activities that may suggest unauthorized access, reconnaissance, malware infection, or other malicious behavior. So anything out of ordinary on the network may seem or may indicate a malicious behavior. And some common indicators include if you have rogue devices, enumeration, anomalous activity, and activity on unexpected ports. So we will discuss each of these one by one. So exam type questions are heavily scenario based and focus on what does this indicate and what is the next step. So you must understand that what each of these indicator or indication means and what happens or what are the, you can say, the attacker steps inside a malicious activity or inside a system compromise. So the first one is rogue devices. So rogue devices are unauthorized devices connected to the network. For example, they may be laptop, Internet of Things devices, Raspberry Pi, or attacker placed some other hardware. So some common indicators include unknown MAC addresses in your DHCP logs or tables. Similarly, devices with no asset management record. So usually organization has record of all the devices inside their asset management. So if a device is not present in the asset management record, it may be rogue device. Or new devices appearing in network scans through when you scan network using an Nmap and Nessus. So some common detection methods include network access control NAC, 802.1x authentication, MAC address filtering and port security, and continuous network monitoring. So these are the detection method, or you can also say these are the protection methods to protect against the rogue devices. Next is the enumeration. So what is enumeration? Enumeration is where attackers actively probe the network to discover hosts, services, user shares, and vulnerabilities. So this is a type of scanning for the resources done by the attackers. So some common techniques and indicators of enumeration include multiple failed login attempts or SMDV/RDP probes, DNS zone transfers or excessive DNS queries, port scanning or service enumeration through Nmap and mass scan, and LDAP or SNMP queries for user and group information. So what logs to check for enumeration? So firewall logs showing repeated connection attempts, SIEM alerts for reconnaissance patterns, and unusual traffic from a single internal or external IP. Next is the anomalous activity. So when the network behavior deviates from the established baseline, that is an indicator of anomalous activity. Key examples include unusual data volumes, unusual data uploads and downloads, traffic to known malicious IP addresses or domain command and control servers, abnormal protocols such as HTTP on port 53 and DNS tunneling, and beaconing behavior, which is periodic small connections and lateral movements between segments inside the organization private network. So some common tools to detect the anomalous activity are SIEM solutions such as Splunk or Microsoft Sentinel. We also have the QRadar from IBM, network behavior anomaly detection, that is ANBAD, Zeek, Suricata, and IDS and IPS solutions. Next is the activity on unexpected ports. So, traffic using non-standard or unexpected ports for a given protocol. So, for example, SSH uses port 22. So, instead, if it uses port 443, it means something fishy is going on. The attacker is hiding the SSH protocol RDP on port 80 or 443. So, RDP usually uses 3389 port number, HTTP and HTTPS on random high ports. So, HTTP uses the port 80 and HTTPS uses port 443. So, if some random ports are used, it is an indication of malicious activity. Non-malware ports, for example, Tetra 4, Tetra 6 for backdoors. So, why attacker use unexpected ports? So, attacker use non-standard ports to bypass firewall rules and security tools. So, for example, firewall may have blocked the port 22 for the incoming traffic, but it may be allowed, traffic may be allowed on port 443. So, to bypass this restriction, they use the non-standard port. Legitimate services usually run on well-known ports. So, some host-related indicators. So, host-related indicators are suspicious activities occurring on individual systems that may suggest compromise, malware infection, unauthorized access, or insider activity. So, some key host indicators include resource consumption, unauthorized software, anomalous activities such as rogue processes, lol bins, file changes and data exfiltration, and unauthorized configuration changes. Detection of host-related indicators include through task manager and resource monitors inside Windows, using the top, htop, and iotop commands in Linux, and using EDR tools such as Microsoft Defender and CrowdStrike. So, unauthorized software and anomalous activities. Unauthorized software are applications that are not used by the organization or by IT. So, the term is used for unauthorized software use, which is shadow IT, using cracked and pirated software, and remote access tools such as TeamViewer, AnyDesk used without approval activity. Suspicious or rogue processes include processes running from unusual locations such as temp, app data, masquerading such as servicehost.exe instead of servicehost.exe. So, using this is 0 instead of O. So, this is the legitimate process and this is a masqueraded process, and high privileges with no clear purpose. So, file system changes and data exfiltration. So, file system changes when a new or changing new or modified critical files, creation of suspicious files in user directories, and alter system files or logs, that is time stomping. Data exfiltration is large outbound transfer to external IP addresses, unusual file access pattern of sensitive data, and use of cloud storage such as Dropbox, Mega, or email for exfiltration. Unauthorized configuration changes is modification to system settings, security controls, or policies without approval. Examples include disabling the antivirus and Windows Defender, changing the firewall rules or registry keys, and adding unauthorized users to admin groups, and modifying the group policy objects or GPUs. So, detection can be done through configuration monitoring tools, fire integrity monitoring, and change management logs. So, some application related indicators. So, service disruption, unexpected crashes or unavailability of critical devices. Services, when services stops or are disabled, for example, security services. Anomalous application activities, when applications are making unusual network connections, when web servers are serving malicious content and database queries showing injection attempts. Some cloud-related indicators, so these include unusual login location or times, high cost resource usage, for example, crypto mining inside the cloud, and abnormal API calls or data transfer. Resource compromise, so compromised storage buckets, for example, public S3 buckets, hijacked virtual machines or containers, and identity and access management role abuse. Next is the social engineering. So in social engineering, we have the typo squatting. So typo squatting registered domain names with slight misspelling of legitimate sites. So this targets users who mistype URLs and land on attacker-controlled pages. For example, we have the popular google.com domain, and if the attacker may register it with the capital I instead of L. So they look similar. Similarly, PayPal. So here we have the 1 instead of L. Amazon, so it is similar to Amazon. So registering the domain with RN, that is similar to M. And Microsoft, so register this domain which have an extra T to typo squat the original Microsoft domain. So purpose is credential theft, malware delivery, and phishing. Another social engineering trick is the URL shorteners. So URL shorteners, such as we have the websites that provide these facilities, such as bit.ly, tinyurl.com, obscure the true destination of a link. So attackers use them to hide malicious URLs in phishing emails and social media. So why attackers use URL shorteners? So they hide malicious domains from email security filters, bypass reputation-based URL blocking, makes link appear legitimate and trustworthy, and can be redirected to new destination after discovery. So analyst actions should be to expand shortened URL before investigating them. So identity-based indicators include identity and access management account compromise. So compromised accounts are the leading cause of breaches. Attackers gain legitimate credentials. Compromised identity and access management accounts provide access while appearing as normal user activity. So indicator of identity and access management account compromise: login from previously unseen IP address or geographic location, successful login after multiple failed attempts through brute force success, login at unusual time. So for example, if the employee usual timing are from 9 to 5, but if the login happens at 3 a.m., it is then an indicator of the compromise. Sudden access to resources the account has never touched before. So these all are some of the indicators of a compromised account. Some identity-based indicators. Unauthorized access occurs when a user accesses resources beyond their authorized scope, and it can be external attacker, compromised insider, or privileged abuse. Key indicators of unauthorized access include access to resources outside the job role, privileged abuse. Privileged abuse means escalating the privileges or using the privileges to do tasks that are not meant to be done. Accessing restricted data and unusual login activity, as we said, that log in at a very unusual time, such as at 3 a.m. Identity-based indicator again include impossible travel. Impossible travel occurs when a user authenticates from two geographically distant locations in an impossible short frame, an impossible short time frame. For example, if a user logins from USA and after 5 minutes same user logins from India, so it is impossible to travel in such a short time from US to India. It means the account is compromised. Strong indicator of account compromised, one login must be from the attacker. So if the legitimate user is from USA, then the attacker may be based in the inside India. For example, user logins from New York at 9 a.m. and same user logins from London at 9:45 a.m. So this travel is physically impossible, and it is a strong compromise indicator. So identity-based indicators considerations include, so we must include some considerations before saying that this indicator is a compromise. So VPNs and proxies can create false positives. So user may route through international VPN. So if the user is using VPN, and let's suppose the user that was using the resources from New York, and now the VPN location is set to London, so this consideration must be kept in mind. Cloud-based system may show logins from data center locations rather than user location. So for example, if the user is using resources or is being logged in from the data center inside London, then the location may be shown as the London. So correlate with other indicators before concluding the compromise. So now coming over to email related attacks. So business email compromise, BEC, is a targeted attack impersonating executives or vendors to trick employees into transferring money or revealing sensitive data. Some common indicators of email compromise include emails with urgent language and unusual request, slight variation in email addresses, for example, CEO@company.com. So here, using this Cyrillic A, again request to update payment details or wire money through spoofed domains. So for example, there is a scenario if the chief financial officer receives email from CEO that asks to wire funds urgently. So this is a classic business email compromise scenario. Objective 1.3, given a scenario, use different tools to determine malicious activity. So now we will study some different tools to determine that what malicious activity is going on. First one is the CyberSecurity, which is used for decoding and parsing. So it is a free web-based tool by GCHQ for decoding, encoding and transforming data. So it is the Cyber Swiss Army knife. And some common uses of this tool include decoding base64, URL encoding, hex and ROT13, parsing logs and extracting indicators of compromises, cracking simple ciphers, and data carving and format conversion. So why it is valuable? Because no installation is required. It supports recipes, that is, you can use saved workflows inside the tool, and it is excellent for malware analysis and obfuscated payloads. Now coming over to packet analysis tools. So packet analysis tools are used to capture and inspect network traffic to identify malicious patterns, command and control communication, data exfiltration or exploits. So some key packet capture or packet analysis concepts include PCAP, which is packet capture, that is the file format storing captured network packets. Promiscuous mode is the network interface card. In this mode, the network interface card captures all the traffic on the segment, not just the traffic that is destined for it. So it listens to and captures all the traffic. Full packet capture is when it captures the entire packet including the payload. NetFlow captures the metadata only, that is IP addresses, port numbers and bytes, not the full payload. And deep packet inspection DPI analyzes packet content beyond headers. So a very popular packet analysis tool is known as Wireshark. So it is most widely used graphical packet analyzer in the world. It is open source and available for Windows, Linux and Mac OS. And it captures live traffic or analyzes saved PCAP files. So key features of Wireshark include deep packet inspection, powerful display filters, follow TCP stream, and expert information, that is to highlight anomalies. Common use cases include analyzing suspicious connections, identify C2 traffic, and reconstructing sessions. For example, the follow TCP stream can be used to reconstruct different sessions. Next, we have the TCP dump. So it is a command line packet capture tool for Linux and Unix systems. It is lightweight, pre-installed on most Linux distributions, and it is ideal for capturing traffic on remote servers where GUI is unavailable, and the output can again be saved as PCAP for analysis in Wireshark. So key components or key commands of TCP dump include TCP dump -i -0. So -i means that interface. So this is the interface that we want to capture traffic on. So after -i flag, you can give the interface number on which you want to capture the traffic. TCP dump -nn port 80. So here you can filter traffic by ports, and -nn means that no name resolution is required. TCP dump -w capture.pcap. So here the TCP dump capture traffic is saved to this file for later analysis. W means, you can say, to write the traffic to this file. So TCP dump is best for quick capture on servers, scripting and automation, and low resource environment. Then we have two another tools, Snort and Suricata. So Snort is an open source Snort is an open source intrusion detection and prevention system. It has a signature-based detection, and it is widely used and highly customizable. So Suricata is modern high-performance intrusion detection and prevention system. It supports multi-threading. It is better for protocol detection and file extraction, and it has the native support for YAML rules. So common use case of these tools include real-time alerting on malicious traffic and analyzing PCAPs offline. Next, we have the Zeek, also known as BRO. So Zeek, formerly known as BRO, is a network security monitoring platform focused on network visibility and behavioral analysis. Key strengths of Zeek includes it generates rich logs such as HTTP, DNS files, and connection logs, protocol analysis and anomaly detection, and scripting language for custom detection. So it is best for long-term network forensics, detecting sophisticated attacks, and extracting files from traffic. For example, a use case scenario for Zeek would be that there is a suspicious domain resolution. So Zeek logs show detailed DNS and HTTP activity for investigation. So these tool comparisons, so CyberChef is for decoding, it is best for data transformation and indicator of compromise. Interface is GUI and its strength is speed and flexibility. Wireshark is for packet analysis. It gives us detailed inspection. Interface is GUI and its strength is user-friendly and deep analysis. TCP dump is again for packet capture. Its strength or it is best for quick capture. Interface is CLI and its strength is that it is lightweight and fast. Snort is intrusion detection and prevention system. It is best for signature-based detection. Interface is both CLI plus rules and its strength is that it has a mature rule set. Suricata is again intrusion detection and prevention system. It is best for high-performance detection. Interface is CLI plus rules and its strength is the modern multi-threaded architecture. And Zeek is for network analysis and it is best for log generation and forensic. Interface is a framework and its strength is rich metadata and scripting. So now coming over to our next topic, that is log analysis through SIEM, that is security information event management. So security information and event management, or SIEM, is a central platform that collects, correlates and analyzes logs from multiple sources. Key capability of SIEM include real-time alerting, correlation rules, dashboards, and compliance reporting. Some popular SIEM platforms are Splunk, Microsoft Sentinel, ELK Stack, and QRadar from IBM. And use cases of SIEM include detecting anomalies across logs, incident timeline creation, and threat hunting. Threat intelligence platform, so we have Open Threat Exchange, that is OTX. So it is free community-driven threat intelligence platform by Alien Vault, that is AT&T Cybersecurity. It is one of the largest open threat intelligence communities globally and it is available at otx.alienvault.com. And what are the analyst use cases? So to look up for suspicious IP addresses found in logs, check file hash from endpoint against known malware databases, subscribe to pulses relevant to your industry sector, and enrich SIEM alerts automatically via OTX API integration. Next threat intelligence platform is malware information sharing platform, that is MISP. So it is open source threat intelligence platform designed for sharing structured threat data. It is developed by CIRCL, that is Computer Incident Response Center in Luxembourg, and it is available at misp-project.org. It is a self-hosted deployment. And analyst use cases include to share indicator of compromises with trusted partner organizations, to receive threat intelligence from ISACs, that is Information Sharing and Analysis Centers, to automate integration of compromise ingestion into SIEM via API, and to investigate relationships between threat actors and malware campaigns. Next is Open Cyber Threat Intelligence, that is OpenCTI. So this open source threat intelligence platform is developed by ANSSI, that is French National Security Agency. It is available at opencti.io, self-hosted or cloud deployment, and it is focused on structured graph-based threat intelligence with rich relationship mapping. So some analyst use cases for the OpenCTI. It can be used to build comprehensive threat actor profiles, visualize attack campaign relationships, track which CVEs are being actively exploited and feed structured threat intelligence into SIEM and SOAR platforms. So CVE, I hope you know, are the common vulnerability and exposures. There is a database of these vulnerabilities, and so this OpenCTI can track which CVEs are exploited. Next is endpoint security. So endpoint detection and response, that is EDR, which monitors and responds to threats at the endpoint level. Core capabilities of EDR include continuous endpoint monitoring and telemetry collection, real-time threat detection using behavioral analysis, automated response, that is to isolate host, kill the process, and quarantine file, threat hunting, which is query the endpoint telemetry across all devices, and root cause analysis, that is to reconstruct full attack chain from initial access to impact. So these are the some capabilities of the EDR, that is endpoint detection and response. So next is extended detection and response, XDR, which correlates data across not only endpoints but endpoints, network, cloud, and email. So XDR extends coverage to endpoints plus network plus emails plus cloud and identity. It correlates data across all layers for unified threat detection. It reduces alert fatigue by linking related events into single incident and provides end-to-end attack visibility across entire kill chain. So these are some of the differences between the EDR and XDR. So both are part of the endpoint security. So with respect to coverage, and EDR is for endpoint only, while XDR is multi-layer, that includes endpoint, network, cloud, and email. Correlation of EDR is endpoint centric, while XDR gives us cross-domain correlation. Alert volume in EDR is higher, while in XDR there are lower and consolidated alerts. Visibility of EDR is deep endpoint telemetry, while the XDR provides broad cross-environment visibility. Next is the MDM in endpoint security. So MDM, mobile device management, manages and secures mobile devices across the organization. It extends endpoint security controls to the mobile devices such as smartphones and tablets, and it is critical as mobile devices accesses corporate email, data, and applications. So security capabilities that are relevant to analysts are device compliance monitoring. So MDM identifies not compliant or jailbroken devices. Remote wipe, using MDM we can erase device if it is lost, stolen, or compromised. App management controls which application can be installed, or it can control the installed application and also block unauthorized application. And certificate deployment, so we can push security certificates for VPN and Wi-Fi authentication to these mobile endpoints. Next is domain and IP reputation. So first one is who is. So who is a protocol and a database that stores registration information for domain names and IP addresses. It is publicly accessible and provides ownership and registration details. So what are some security capabilities that are relevant to the analyst of this who is protocols? So these include the domain registrant name, organization, and email address, registration date and expiration date, name server and DNS configuration, registrar information, IP address assignment, and ASN, that is autonomous system number. So Abuse IP DB is a free community-driven database of IP addresses reported for malicious activity. It is available at abuseipdb.com. It provides crowdsourced reports from security professionals and automated systems worldwide. So some abuse categories include port scanning, SSH brute force, and file transfer protocol brute force. Web application attacks like SQL injection and cross-site scripting, spam and phishing source DDoS attack participation, and malware command and control server. Geolocation by IP, GeoIP. So GeoIP maps IP addresses to geographic locations. It provides country, region, city, internet service provider, and ASN information for an IP address. So some analyst use cases include GeoIP is an approximation and not perfectly accurate. Attacker use VPN, Tor, and proxy chains to mask true location. Cloud provider IPs such as AWS, Azure, and GCP resolve to data center locations, not user location, and use as one indicator among many, not a definitive conclusion. So now coming over to some file analysis tools. So first one is string. So string is a command line tool that extracts human readable text from binary files. It is pre-installed on Linux and available for Windows via sys internals. It is one of the first steps in static malware analysis. So why strings analysis matter? So malware often contains readable artifacts such as URL, IP addresses, registry keys, and error messages. So it reveals attacker infrastructure embedded in malware samples. It identifies capabilities, that is, file paths suggest what malware targets, and no execution is required, so it is safe static analysis technique. Next is VirusTotal. So it is a free online multi-engine malware analysis platform which is owned by Google. It is available at virustotal.com. It scans files, URLs, domains, and IP addresses against 70 plus antivirus engines simultaneously. So some key features of VirusTotal include file scanning. So you can upload file for analysis against all antivirus engines. Hash lookup. So it is hash or search by MD5, SHA-1, or SHA-256 without uploading file. URL and domain analysis. So it checks for URLs and domains for malicious content. Behavior analysis. So dynamic analysis, sandbox results. Community commands. So analysts can comment and there. So analyst notes and observation can be seen on this virustotal.com. And relations graph. So it visualizes connection between files, IP addresses, and domains. So next is Yara. So Yara is a pattern matching tool used to identify and classify malware. Full name of Yara is yet another recursive acronym. It was created by Victor Alvarez at VirusTotal, and it is considered the Swiss Army knife of malware research. So how Yara works? So analyst writes rules describing characteristics of malware. Yara scan files, memory, or network traffic for matches and returns match if file contains the defined pattern. So common analyst use cases include to scan endpoints for known malware family indicators, hunt for specific malware across enterprise using EDR integration, identify malware variants sharing code with known samples, and detect web shares on web servers. Next is sandboxing. So sandboxing executes suspicious files in an isolated and controlled environment. You can safely observe malware behavior without risk to the production environment and systems, and it captures dynamic behavior that static analysis tools cannot reveal. So what does the sandbox captures? Network connection made by the malware, files created, modified or deleted, registry keys added or modified, processes spawned and injected into, system calls and API usage, screenshots of malware execution and DNS queries and HTTP requests. So some sandboxes example, first one is Joe Sandbox. So it is a commercial sandbox platform with free community tier. It is available at joesandbox.com. It is known for extremely detailed and comprehensive analysis reports. So some key features of Joe Sandbox include multi-OS support. So it supports Windows, Linux, macOS, Android and iOS analysis. Hypervisor level analysis, so it detects sandbox aware malware that tries to evade detection. Full behavior reports, network, file system, registry, process and screenshot analysis. MITRE attack mapping, so it maps observed behavior to MITRE platform or MITRE attack techniques automatically. Yara and Sigma rules, so it auto-generates detection rules from analysis. So some analyst use cases for Joe Sandbox. So you can submit suspicious email attachment for safe analysis. It can analyze malware sample from incident response engagement. It can generate indicator of compromises from malware behavior for SIEM blocking rules and validate threat intelligence reports against real-time malware samples. Next is the Cuckoo Sandbox. So it is most widely deployed open source automated malware analysis sandbox. It is self-hosted, so organization controls data and there is no external sharing, and it is available at cuckoosandbox.org. Key features of Cuckoo Sandbox include that it is free and open source, so you have full control over deployment and data. It has modular architecture, so it extends with custom analysis module. Multiple VM support, so it can analyze against different Windows and Linux configuration. Network analysis, so it captures and analyzes all network traffic during execution. Memory analysis, so it integrates with volatility for memory forensic. And web interface, so it has easy submission and report viewing. So difference between the Joe and Cuckoo Sandbox. So with respect to cost, Joe Sandbox is commercial, but it has a free tier as well. Cuckoo Sandbox is free and open source. With respect to deployment, Joe Sandbox is cloud-based, while Cuckoo is self-hosted on-prem. Evasion resistance of Joe Sandbox is high, while for Cuckoo it is moderate. Setup complexity for Joe Sandbox is none since it is cloud-based, while for Cuckoo it is of course high since the customer has to deploy it in its own infrastructure. Data privacy in Joe Sandbox, it is external since it is cloud-based, while in Cuckoo the data resides inside your internal network. And report depth in Joe Sandbox is very detailed, while in Cuckoo it is good. Next is the pattern recognition that with regex or regular expressions. So regular expressions are patterns used to match, search and extract text. So these are fundamental skills for log analysis, threat hunting and SIEM rule writing. And regex is used across SIEM platforms such as Splunk, grep, Python and security tools. Examples include to find email addresses, IP addresses, file names and log entries. Some analyst use cases include SIEM searches, log analysis, and threat hunting. So, next is the pattern recognition, interpreting suspicious commands. So, analysts must recognize malicious command patterns in logs, EDR, telemetry, and SIEM alerts. So, attackers use built-in OS commands to avoid detection. So, LOL-bin's knowledge is essential. Next is email analysis, that is MX Toolbox. So, it is free online email and DNS diagnostic platform. It is available at mxtoolbox.com. It is essential tool for email header analysis and domain email security investigation. So, business email compromise investigation workflow with MX Toolbox can be done. You need to extract full email headers from suspicious email, paste it into MX Toolbox header analyzer, identify true originating IP address, check originating IP address IP against abuse IPDB, verify SPF, DKIM and DMARC results, check sender domain registration date via WHOIS, and confirm findings and escalate. Next is user and entity behavior analytics, that is UEBA. So, UEBA analyzes patterns for behavior of users and entity, that is devices, applications and services. It establishes behavioral baselines and alerts on significant deviation. It goes beyond rule-based detection, so it uses machine learning to identify anomalies. So, how user and entity behavior analytic works? So, it collects data from SIEM, Active Directory, HR systems, data loss prevention, and endpoint tools. It builds behavioral baseline for each user and entity over time. It assigns risk scores to users and entities based on observed behavior and alerts when behavior deviates significantly from established baseline. Open UBA. So, open source UBA platform is community driven alternative to commercial solution. It is available at openuba.org. It is built on open source stack, that is Elasticsearch, Logstash and Kibana, known as ELK. And key features include behavioral analysis, behavioral baseline modeling for users and entities, pre-built analytics for common insider threats and account compromise scenarios, integration with standard log sources, Active Directory, Windows event logs and proxy logs, customizable detection models, tailor analytics to organizational baseline, dashboard and virtualization layer for analyst workflow. So, our next topic is file formats. So, security analysts encounter multiple data formats when analyzing logs, threat intelligence feeds, configuration files, and security tool outputs. Understanding how to read and parse these formats is essential for effective log analysis, SIEM ingestion, and automation scripting. So, JSON is JavaScript object notation. So, it is lightweight, human readable data interchange format. It is most widely used format in modern security tools, APIs, and log output. And native output format for Suricata, EVE logs, Zeek logs, Cloud Audit logs, and REST APIs. So, some file formats, first one is XML. So, it is tag-based markup language for structured data representations. It is older format but still widely used in enterprise security tools and Windows event logs. It is more verbose than JSON but supports complex hierarchical data structures. So, security tools that use XML. So, window event logs are native XML format underneath EVTX. NetSup and Nmap So vulnerability and scan reports of these tools are in XML format. SIEM import, so many SIEMs accept XML formatted log feeds. SAML authentication, so SSO, that is single sign-on assertions, use XML formats. And SNOT rules, so some rules export formats use XML. Next is YAML, that is YAML and markup language. So it is human readable data serialization format. It is commonly used for configuration files and security tool rule definitions, and it is more readable than JSON and XML, that is minimal syntax indentation based structure. So security tool YAML usage, so Sigma rules, vendor neutral SIEM detection rules are written in YAML. Ansible playbooks, so security automation and configuration management, these are also written in YAML. Kubernetes manifest, so container security policy definition. Docker compose container deployment configuration files, and GitHub Actions security pipeline automation workflow. So these are tools use YAML. Next is EVTX, which is Windows Event Log format. So it is binary log format used by Windows Vista and later for storing Windows event logs. It replaces older .evt format and it is more structured and efficient. It contains all Windows security system and application events. So tools for EVTX analysis, first one is Windows Event Viewer. So it is built-in GUI for browsing event logs. PowerShell get when event, so it can be used to query and filter events via command line. ChainSaw is fast EVTX hunting tool using Sigma rules. EVTX ECMD, it is Eric Zimmerman's EVTX parser and it exports to CSV and JSON. And Hayabusa is window events log, fast forensics and threat hunting. Now coming over to programming and scripting languages. So analysts are not expected to be software developers, but they should understand how scripts are used for automation, investigation and attacks. So Python is most widely used programming language in cybersecurity. It is versatile and used for automation, log parsing, malware analysis, tool development and API interaction. It has a rich ecosystem of security-focused libraries. So why Python for security analysts? So it is simple and has readable syntax. So it has low barrier to entry, extensive standard library, file handling, networking and regex are built in. It has rich third-party security libraries. It can be used cross-platform. It runs on Windows, Linux and Mac OS. And it is dominant language for SIEM automation and SOAR playbooks. Next is PowerShell. So it is Microsoft's task automation and configuration management framework. It is built into all modern Windows system and no separate installation is required. It is essential for Windows incident response, log analysis and security automation. So why PowerShell is necessary for security analysts? So it has deep integration with Windows. It gives access to event logs, registry, Active Directory and WMI. It has pipe-based command chaining. You can chain commandlets for powerful one-liners. Remoting, so it can execute commands on remote systems during incident response. And it can be used by both attackers and for both attacker and defender too. So analysts must understand both use cases. Shell scripting, so shell scripts automate tasks in Linux and Unix environments using command line interpreters. So primary shells, that is bash, is most common. Similarly, we have shell, Z shell and fish. These are essential for Linux-based security tools, log analysis, and incident response automation. So why shell scripting is important for security analysts? So Linux dominates server infrastructure, so most security tools run on Linux. It automates repetitive log analysis tasks. It can chain multiple security tools together in automated pipelines. It is essential for DFIR, that is digital forensic and incident response on Linux system. And it is lightweight and requires no additional runtime or libraries. Objective 1.4 explain threat intelligence and threat hunting concepts. So what is threat intelligence and threat hunting? Threat intelligence is knowledge about existing or emerging threats, including actors, TTPs, and IOCs. TTPs is tactics, techniques, and processes, and IOC is indicator of compromises. Threat hunting is proactive search for threats that have bypassed preventive controls. That is, it assumes breach, that the breach has already taken place. And the goal is to move from reactive to proactive security using intelligence-driven defense. So what are the threat actors? So threat actors may be advanced persistent threat, that is APTs. So these are highly skilled, well-funded groups, often nation-state sponsored. They maintain long-term access. They are stealthy and focused on espionage or sabotage. Example of some APTs include APT28, also known as Fancyware, and APT41. So some APT characteristics are that they are advanced, they use custom malware, zero-day exploits, and sophisticated techniques. They are persistent, so they maintain long-term access, sometimes for years, without detection. And their approach is targeted, so they have specific objectives, and these may be espionage, intellectual property theft, sabotage, or financial gain. Next is the insider threat. So these are malicious or negligent internal employees and contractors, and they can cause significant damage due to legitimate access to system and network. Insider threat indicators include accessing data outside normal job function and normal job hours, downloading unusually large volumes of data, attempting to access systems beyond authorization, working odd hours with no business justification, expressing dissatisfaction or planning to leave organization, disabling security tools or clearing audit logs, and connecting unauthorized storage devices. So next is tactics, techniques, and procedures, that is TTPs. So TTPs describe the behavior and methods used by threat actors. They are most valuable intelligence for defenders, harder to change than IOCs, that is indicator of compromises. So TTP hierarchy is, we have tactics. So these are high level goals or objectives, for example, initial access, persistence, or exfiltration. Techniques are the specific methods used to achieve tactics, that is spear phishing, registry run keys, and procedures are specific implementation details of techniques such as exact commands, tools, and scripts used. Heat maps are visual representation of threat activity frequency and intensity across an environment, and they use color gradients to show concentration of threats, attacks, or vulnerabilities. So analyst values for heat maps and TTP are to quickly identify highest risk areas that require immediate attention, to prioritize remediation effort based on attack concentration, communicate security posture to management visually, track changes in attack pattern over time, identify blind spots, areas with no coverage or visibility. Next is a pyramid of pain. So it is framework created by David Bianco describing the relative difficulty of using different indicator of compromise type. And higher on the pyramid means more painful for attacker when defender detects and blocks it. So it guides analysts on where to focus detection efforts for maximum impact. So key takeaways for analysts are that most security teams focus on hashes and IPs, which are lowest value and easiest for attacker to change. So the shift should focus to detecting TTPs and tools for durable and high value impact detection. So as we can see these areas, so this is the pyramid of pain. So the higher we go, the more the pain. So we should focus our tools on these high value targets rather than on hash value or IP addresses. So MITRE ATT&CK framework is a globally accessible knowledge base of adversary tactics and techniques. It is based on real-world observation of threat actor behavior. It is available at attack.mitre.org and it is used by defender worldwide for threat modeling, detection engineering and gap analysis. So why analysts use it? So analysts use it for threat hunting, incident response, threat intelligence and security assessments. So the MITRE ATT&CK framework or structure include 14 tactics. This is the why means the adversary goals, techniques are the how. These are the methods used by adversary to achieve goal. Sub-techniques are specific variations of technique and procedures are real-world implementations by specific threat actors. The attribution is the process of identifying the threat actor responsible for an attack. It is one of the most challenging aspects of the threat intelligence and it requires correlation of technical, operational and strategic intelligence. So attribution indicators include technical, these are malware code similarities, reused infrastructure and TTPs matching known groups. Next is operational, these are attack timing, business hours in specific time zones, target selection patterns. Next is strategic, so geopolitical context, victims aligned with nation-state interest. And last one is linguistic, which is language artifacts in malware code, error messages or C2 communications. Confidence level impacts. So first one is timeliness. So threat intelligence loses value rapidly if not delivered and acted upon quickly. So time-sensitive intelligence must reach the right analyst before the threat windows closes. So impact of poor timeliness is that indicators are blocked after attacker already achieved the objectives, defenders acting on outdated infrastructure that attacker abandoned, missed detection windows for active intrusion and intelligence sharing delays reduce collective defense effectiveness. Relevance is intelligence is only valuable if it applies to your specific environment, industry or threat profile. It is irrelevant. So irrelevant intelligence creates noise and alert fatigue. So building relevance filters is to profile your organization's threat landscape, that is industry, geography and technology. Subscribe to sector-specific threat intelligence, that is ISACs. Tag intelligence feeds by relevance category and score incoming intelligence against your environment profile before actioning. Next is accuracy. So inaccurate threat intelligence is worse than no intelligence. It drives incorrect defensive actions. False positive waste analyst time and damage trust in intelligence program. So impact of inaccurate intelligence is blocking legitimate IP addresses, causing business disruption, wasting investigation time on false positive alerts, missing real threats while chasing inaccurate indicators, and eroding confidence in threat intelligence program among stakeholders. So intelligence collection methods and sources, and the first one is OSINT, that is open source intelligence. So OSINT is intelligence gathered from publicly available resources. It is free to collect and requires skill to analyze and contextualize. It is widely used for threat actor research, attack surface discovery, and indicator of compromise enrichment. So some key OSINT tools include Shodan. So Shodan is a search engine for internet connected devices and services. Next is Maltigo, which is a visual link analysis and OSINT investigation platform. The Harvester gathers emails, domains, IPs from public sources. Recon-NG is a modular web reconnaissance framework, and Spiderfoot is automated OSINT collection platform. So what are some closed source intelligence platform, and what is the closed source intelligence? So closed source intelligence is also known as proprietary or commercial threat intelligence. It is collected through non-public channels, and it requires purchase, partnership, or privileged access. So the closed source intelligence over OSINT include that closed source intelligence is of higher quality and contains more thoroughly vetted data. So closed source intelligence access is not publicly available. It has a dedicated analyst teams curating and contextualizing data, and it has faster time to intelligence for emerging threat and direct researchers relationship for clarification. So if you purchase this closed source intelligence, you may have direct researcher relationship for clarification. Next is threat intelligence sharing. So sharing threat intelligence amplifies the defensive value. What one organization discovers protect all the organization if it is shared with all other organizations. And formalized sharing uses standard formats and protocols. So the information that is shared through threat intelligence include malicious, let's suppose malware or malicious information, IPs, domain names, hashes, TTPs, and threat actor information. Next is the indicator of compromise, IOC. So IOCs are artifacts observed on a network or system that indicate a potential intrusion. So it is digital forensic evidence that a security incident has occurred or is in progress. So the IOC provides digital forensic evidence about a potential security incident that has either occurred or is in progress, and it can be used to detect, investigate, and respond to threats. IOC life cycle include the first phase is of course the collection. So gather IOCs from incidents, threat feeds, and intelligence sources. Next is analysis. It is to validate, enrich, and contextualize raw IOCs. Next is application of IOC, to deploy IOCs into security tools for detection and blocking, and then review to monitor effectiveness and retire aged or inaccurate IOCs. So the IOC collection, IOCs are collected from multiple sources. They may be internal or external. So internal collection sources include incident response investigations, malware analysis produces hashes, IPs, and domains, SIEM alerts, so suspicious events reveal potential IOCs, endpoint detection and response telemetry, so endpoint activity logs reveal malicious artifacts, firewall and proxy logs, so these identify suspicious connections, and email security gateways extract IOCs from phishing campaigns. Next is external collection sources. So these include threat intelligence platforms such as OTX, MESP or OpenCTI that we already studied in our previous slides, commercial threat feeds, ISAC sharing communities, government advisories such as CISA alerts, FBI flash reports, open source malware repositories that is Malware Bazaar, and security vendor research blogs and reports. Next is the IOC analysis. So raw IOCs required validation and enrichment before operational use. Poor analysis leads to false positive and wasted analyst time. Next is IOC application and usage. So validated IOCs must be operationalized into security controls to provide defensive value. So we have mainly two types of IOCs. First one is the atomic indicators. So atomic IOCs are the simplest, most specific indicators. They cannot be broken down further. They are easy to collect and deploy but lowest on the pyramid of pain. So they are trivial for attackers to change. It means that attackers can easily change them if they are collected by the defensive teams. So what are the limitations of atomic IOCs? So they have short lifespan, attackers rotate IP addresses and domain rapidly, high false positive risk. So shared IPs, CDNs and cloud providers used by both malicious and legitimate traffic. It has no context, so a hash value alone does not explain what malware does or why it is dangerous. Next is the behavioral indicators. So behavioral IOCs describe pattern of activity rather than specific artifacts. They are higher on the pyramids of pain and much harder for attackers to change, and this type of IOC forms the basis of advanced threat detection and hunting. So a comparison between behavioral and atomic IOCs. So the aspects include specificity. So atomic is very specific while behavioral is pattern based. Attackers effort to evade. So in atomic, the attackers require minimal effort to evade, while in behavioral, the attackers need significant effort to evade. Detection durability of atomic is short-lived, while behavioral is long-lasting, and false positive rate of atomic IOC can be very high, while it is lower with tuning for behavioral. And detection method for atomic is blacklist matching, while for behavioral, it is behavioral analytics and SIEM rules. So our next topic is threat modeling. So threat modeling is a structured process to identify, assess and prioritize potential threats. So it is performed during system design or security assessment, and it assesses what can go wrong, how likely is it, and what we do about it. So some threat modeling models you can say. First one is STRIDE. So STRIDE is a threat categorization framework developed by Microsoft. It is used to systematically identify threats against systems and applications. So STRIDE basically stands for each of these letter in STRIDE stand for S for spoofing, T for tampering, R for repudiation, I for information disclosure, D for denial of service, and E for elevation of privileges. So what are the security property violated by each of these threats? So spoofing violates the authentication, and an example is attacker impersonates as a legitimate user. Tampering violates the integrity, so attacker modifies data in transit or data at rest. So security property by repudiation that is violated is non-repudiation. For example, user denies performing an action with no audit trail. Information disclosure basically violates confidentiality. For example, sensitive data exposed to unauthorized parties. Denial of service violates availability, so system is made unavailable to legitimate users through denial of service. Elevation of privileges violates the security property of authorization. So in this violation, user gains higher privileges than they are authorized. Next is threat mapping. So threat mapping connects identified threats to your specific environments, assets, and controls, and it links threat intelligence to defensive architecture decisions and bridges the gap between abstract threat data and concrete security actions. So threat mapping process include identifying assets, so what you are protecting, data, system, and infrastructure. First, these must be identified. Next is to profile threat actors, so who is likely to target you based on industry and geography. Next is map TTPs, so which attack techniques does this actor use. Then the assess coverage, so do you have detections for these techniques, and last is to identify gaps, which are techniques with no detection or prevention. Our next topic is cyber deception. So cyber deception uses deliberate false information and decoy resources to mislead attackers. It detects threat earlier in the attack life cycle, often before real damage occurs, shifts the advantage to defender. Attacker wastes time on fake assets. So cyber deception can be done through honeypots and honeynets, decoy credentials and files, fake systems or data, and moving target defense. Objective 1.5 explain the importance of efficiency and process improvement in security operations. So what is process improvement and efficiency? So modern security operations centers face an ever increasing volume of alerts, threats, and data. Manual processes cannot scale, so analysts suffer alert fatigue and burnout. So process improvement transforms a reactive security operations center into a proactive, efficient security operation. So there are three pillars of SOC efficiency, and these include: first one is standardize, which is consistent, repeatable processes. Streamline is to automate and enrich to reduce the manual effort, and integrate connects tools to eliminate silos and manual handoffs. So what are standardized processes? So standardization ensures that every analyst responds to threats the same way every time. It eliminates inconsistency, reduces human error, and enables measurable improvement. And it is a foundation of a mature security operation program. Key practices of standardization include to develop and maintain playbooks, which are step-by-step guides for common scenarios, to develop runbooks, which are detailed technical procedures for specific tasks, and document escalation procedures and roles/responsibilities. A real-world impact of standardization is that standardization incident response playbook reduces response time from hours to minutes. Streamline operations goal is to eliminate manual repetitive tasks and improve overall security operations center efficiency. So automation and orchestration is to develop and maintain playbooks, which are step-by-step guides for common scenarios, develop runbooks, which are detailed technical procedures for specific tasks, and document escalation procedures and roles and responsibilities. Streamline operation through SOAR, that is security orchestration and automation response. So SOAR is security orchestration, automation, and response. It is a platform that connects security tools, automates repetitive tasks, and orchestrates response workflow. It addresses the core SOC challenge, that is too many alerts and too few analysts. So SAR benefits include reduce mean time to recover from hours to minutes. For common incident types, it handles 10 times more alerts with same analyst head count. It has consistent response, so automation never skips steps, and analysts' focus shifts to complex investigations requiring human judgment. So a SAR playbook example, for example, a phishing response. So email is flagged by the security gateway, which is triggered by SAR, or SAR is triggered. So SAR automatically extracts IOCs from email, that is the sender, URLs and attachments. It checks the IOCs against VirusTotal, OTX, abuse, IPDB simultaneously. If the IOCs are malicious, it automatically blocks the sender domain in email gateway. It searches the SIEM for other users who received same email. Create incident ticket with all findings pre-populated. Notify the affected user automatically and assign to analyst for final review and closure. So automation and orchestration, that is infrastructure as a code, IAC. So infrastructure as a code manages and provisions infrastructure through machine readable configuration files. Infrastructure defined in code, so version controlled, repeatable and auditable. It transforms manual infrastructure setup into automated, consistent deployments. IAC security scanning to identify misconfigurations before infrastructure is deployed. Check for open security groups, unencrypted storage and excessive identity and access management permission. Tools include CheckOV, TerraScan, TFSec and AWS Cloud Formation Guard. Next is data enrichment. So data enrichment automatically adds context to raw security alerts and events. It transforms a bare IP address or hash into a rich, actionable intelligence artifact, and it dramatically reduces the investigation time. So context provided before analyst begins work. So some enrichment data sources include threat intelligence platforms such as OTX, MISP, VirusTotal and Abuse IPDB, GeoIP datasets, that is geographic location of IPs, WHOIS data, which is domain registration information, asset inventory, internal system ownership and criticality. HR systems include the user identity, role, department and employment status. Vulnerability scanners for known vulnerabilities on affected hosts. So we already went through this. The rules and alert tuning. So alert tuning reduces false positive and false negatives to improve detection quality. So poorly tuned rules create alert fatigue, that is analysts ignore alerts and real threats are missed. Continuous tuning is essential, so environment and threats constantly evolve. So tuning process is number 1 to identify highest false positive rules, number 2 to analyze root cause of false positive, number 3 is to add targeted exceptions without breaking detection logic, number 4 is to test in shadow mode before production, and number 5 is to monitor and document all changes. Next is in data enrichment is dashboard creation. So dashboards provide real-time situational awareness for different audiences. So dashboards provide real-time situational awareness for different audiences. So this sentence is of course repeated. So best practices are to maintain maximum 6 to 8 widgets per dashboard, such as here we can see we have 6 widgets. Consistent color coding, that is red, amber and green, and to show trends, not just current state. auto refresh for operational dashboards, and separate views for analyst, manager, and CISO audiences. Our next topic is technology and tool integration. So, siloed tools slow down operations. Integration creates a unified security ecosystem. So, key integration methods include through APIs. So, APIs allow tools to communicate programmatically, that is SIEM pulling data from EDR. Webhooks, so real-time event notification, for example, alerts from one tool trigger action in another. Plugins and connectors, so pre-built integrations, for example, Microsoft Sentinel connectors and Splunk add-ons. So benefits include single pane of glass for analysts, faster data correlation, and automated cross-tool workflows. So our last objective of domain 1, objective 1.6, is to summarize concepts related to the use of AI in security operations. So AI in security operations, so use of artificial intelligence, that is machine learning, generative AI, etc., to enhance detection, analysis, response, and automation in security operations. Benefit of using AI is faster analysis, better pattern recognition, reduced manual workload, and improved threat detection. Some challenges with AI include new risks introduced by AI itself, which requires careful governance. So some risks introduced by AI, first one is hallucination. So AI models sometimes generate confident but completely fabricated information. These are called hallucinations. Model produces plausible sounding but inaccurate output. And they are particularly dangerous in security operations where accuracy is critical. Security impact of hallucination is that AI recommends incorrect remediation steps during incident response. AI generates false IOCs that waste analyst investigation time. AI misidentifies benign activity as malicious or vice versa. And AI produces fabricated CVE details or threat vector attribution. The next AI risk is data exposure. So AI tools process data submitted to them, creating risk of sensitive data leaving the organization. So analysts may unknowingly submit confidential data to external AI platforms. Exposure scenarios include analysts paste customer personally identifiable information into public AI chatbot for log analysis. So proprietary source code submitted to AI coding assistant, incident details including unreleased vulnerability information shared externally, and AI training on organizational data exposes sensitive information to other users. Next AI risk is the model poisoning. So model poisoning attacks manipulate AI model training data to corrupt the output. So attackers influence what the AI learns, causing it to make incorrect decisions. Security impact of model poisoning is that compromised AI detection model misses real threats systematically. Attacker knows which techniques will evade AI-based detection. Poisoned threat intelligence models provide inaccurate risk assessments. Mitigation includes to validate the training data sources, use trusted and verified data sets, to monitor model performance over time. Sudden accuracy drops may indicate the model poisoning, and to implement model integrity checks. Next risk is the malicious prompts. So attackers craft input designed to manipulate AI systems into unintended behavior. So there are two primary attack types. First one is the prompt injection, and next is the jailbreaking. So in prompt injection, attackers embeds malicious instructions within data processed by the AI. AI follows attacker instruction instead of legitimate user instruction. An example is malicious email contains hidden text instructing AI email assistant to forward all emails to the attacker. Next one is the jailbreaking, which is crafting inputs that bypass AI safety restrictions and guardrails. It tricks AI into generating harmful content or ignoring security policies. Example is framing malicious request as fictional scenario to bypass the content filters. Next AI risk is malicious prompts. So malicious prompt security impacts include AI security tools manipulated to ignore specific threats, AI assistants leaking sensitive information via crafted queries, and AI-powered automation executing unintended actions. Mitigation includes to use input validation and sanitization for AI processed data, privilege separation, so AI operates with minimum required permission to monitor AI inputs and outputs for anomalous patterns, and regular adversarial testing for AI security tools. Now coming over to AI governance, that is legal and regulatory compliance. So AI usage in security operations must comply with applicable laws and regulations. Regulatory landscape for AI is rapidly evolving globally. So specific compliance requirements include data residency. So AI processing may move data across borders, violating data sovereignty laws. Explainability. So some regulations require ability to explain automated decisions. Bias and fairness. So AI decisions must not discriminate unlawfully. Human oversight. So here high risk AI decisions may require human review before action, and audit trails, so documented AI assisted decisions for regulatory review. AI usage policies include, so organization must define clear policies governing how AI tools are used in security operations. Policies protect the organization from AI related risks while enabling productive AI usage. AI usage policies include to define what data can be and cannot be sent to AI tools, require human oversight for critical decisions, classify AI tools, internal versus external and approved versus unapproved, and audit AI decisions and maintain accountability. So some AI use cases include comparing artifacts, so quickly compare malware samples, file versions or configurations, analyzing log files to identify anomalies, summarize large log volumes and detect patterns, document creation, so auto-generate incident reports, playbooks or summaries, incident investigation, assist in timeline creation, root cause analysis and hypothesis generation, event correlation, so link related alerts across SIEM, EDR and network tools more effectively, and automation and orchestration, so power, SOAR, playbooks, auto enrichment of alerts and intelligent response actions. So key takeaways include, so AI has certain advantages which include significantly improved speed, scale and accuracy in security operation center operations. Major risks include hallucinations, data exposure, model poisoning and prompt injection. So governance of AI is critical, so always combine AI with human oversight and strong policies. And a balanced approach is needed, which is to use AI to augment analysts, not replace them. So that's all for this domain number 1. So this domain was considerably long, so that's why I went through very fast through the slides so that I can reduce the overall time of this video. So I hope this has been informative. So please like and subscribe for the upcoming videos. See you soon.